Hello everyone, welcome to my channel IGCSE and GCSE Maths School. This channel posts videos daily on mathematics for variety of examinations such as Edexcel IGCSE, Cambridge Oral, GCSE, SAT exam, CAT exam, PSAT exam, and NMSQT exams, right? Then I am Saman. We have on a series of videos these days that is on rounding of upper bound and lower bound. Now we have done quite a lot of videos on this part of mathematics, and you go to my channel and watch those videos also. And today's video is on upper bound and lower bound of sum of corrected values. Right now, here are before we have learned how to found the upper bound and lower bound of single corrected values. Upper bound of single corrected value, lower bound of single corrected value, and range of actual values round about that particular single corrected value. Now today we are going to see how the upper bound and lower bound of sum of two corrected values is found, and how the range of that sum of the two corrected values can be written. So they are the two points that we are learning today in this video. Straight go to the video. Then what is the upper bound is said to be the maximum value that can be rounded to a given corrected value. Now here we learn the upper bound of two upper bound sum of two corrected values, then upper bound of sum, then maximum sum of the two corrected values, and the lower bound of sum of two corrected values, that's the minimum sum of the two corrected values. Now how do you find the upper bound of sum of two corrected values? Then there is a formula for that. Upper bound of sum of two corrected values is equal to the sum of the upper bounds of the two corrected values. Then upper bound of the sum of two corrected values is equal to the sum of the upper bounds of the two corrected values. Then there's another formula for finding the lower bound. Lower bound of sum of two corrected values is equal to the sum of the lower bounds of the two corrected values. Lower bound of sum of two corrected values is equal to the sum of the lower bounds of the two corrected values. They are the formula. Then how do you write the range? Then range is what the possible sum, otherwise the actual sum is greater than or equal the lower bound of the sum of the two corrected values, but less than the upper bound of the sum of the two corrected values. So these are the points that we discussed. Then go to the board and see. Now we have written the two formulae for bound, upper bound and lower bound, and the statement for the range of actual sum. Right now, the upper bound of sum of the two corrected values is equal to sum of the upper bounds of the two corrected values. Then lower bound of sum is equal to sum of the lower bounds of the two corrected values. Then range of the sum equals actual sum greater than or equals lower bound of the sum, and less than the upper bound of the sum. Okay, so that is the of course how you find those things. We can now go to an example. Right, we try around two examples. Right. Okay, now they have given a question here. See. Example, if A equals 20 to nearest 10 and B equals 0.5 correct to one decimal place, then they ask find the upper bound of A plus B, that means sum of the two corrected values A and B, and the lower bound of the sum of A plus B, that is the sum of the two corrected values A and B, and range of sum. So those are the things that we have to find in that example. Now we'll see how they find. Now say what is the principle. Then we write upper bound of the sum of Upper bound sum. We can write sum as like this. Upper bound of A plus B. That is the sum. Then equals upper bound of A plus upper bound of B. Right. Upper bound of A plus upper bound of B. Right. Okay. Now, right, we will find them. Then we have to find the upper bound of A first of all. We need the upper bound of A. Upper bound of A. Upper bound of A. What is the corrected value plus degree of accuracy? Accuracy over 2. Right. If I apply that formula, find the upper bound of A and B. Right. Upper bound of A. They say A to the nearest 10. Then 20 is the degree of accuracy. This is for A. This is for A. Right. Then write upper bound equals degree of accuracy of corrected value. Corrected value is 20. Plus then degree of accuracy. How do you find the degree of accuracy? To nearest 10. Then go to 10th place here. 0. Then degree of accuracy is very clear, it is 10. No problem. Right. 10 over 2. Then this will be how much? Then 10 divided by 2, 5. Then 5 plus 20 is 25. Then upper bound of B. Upper bound equals how much? Again the corrected value. What is the corrected value of B? That is 0.5. 0.5. Then plus. They say degree of accuracy 1 decimal place. 1 decimal place. Now we have learned already how to get the corrected value when the to be applied in the upper bound and lower bound formula when the number has been given correct to 1 decimal place. 1 decimal place means we have done one video. Go to that video and check. That must be, I think, in finding upper bound and lower bound of decimal place. Finding upper bound and lower bound of the numbers corrected to decimal place. Decimals. That must be the video. Go to the playlist. You get rounding off and upper bound and lower bound. So that is the playlist. Go to the playlist and find this video and watch. That is upper bound and lower bound of that is the title of the video. Upper bound and lower bound of numbers correct to decimals. So that is the title of the video. Right. Go to that and see. Then this is the way we did it in that one. Then when the upper bound, when the number has been corrected to 1 decimal place, degree of value to be used in the upper bound and lower bound formula is 0.1, decimal 1, 0.1, 0.1 divided by 2, right? Okay. 0.1 divided by 2 means 0.05. Then you add those two, you get 0.55. Okay. That is the upper bound of A, and then you substitute this, right? Okay. Upper bound of A. What is the upper bound of A? 25. What is the lower bound of upper bound of B? Upper bound of B. Yes, upper bound of B. Upper bound of B, how much? 0.55. 0.55. After adding these two, we get how much? 25.55. So that will be the what? The upper bound of the sum of A and B. Upper bound of sum of A and B. Right. Now we are going to find the lower bound. What is the lower bound formula? The lower bound formula I will erase this. Okay, now lower bound formula. The lower bound formula is what? Here we get lower bound of sum is equal to the sum of the lower bounds of the numbers, right? Then you get lower bound of sum like this. Lower bound of A plus B, right, equals lower bound, sum of the lower of A plus lower bound of B. Right. Now we find the lower bound of A. What is the lower bound formula? Then what is the lower bound formula? Lower bound formula equals corrected value minus degree of accuracy over 2. Lower bound formula equals corrected value minus degree of accuracy over 2. Right. Now A, we will find the lower bound of A. This be substituted for that formula to find the lower bound of sum of A and B. Right. Now lower bound, what is the corrected value? Corrected value is 28. Then substitute. Lower bound equals corrected value is 20. Then minus degree of accuracy is 10. It is given right here. It's very easy. Then how much? It will be how much? 20 minus 5 means 15. So that is the lower bound, right, of A. Then lower bound of B. I'll write lower bound of B here. Lower bound of B. Lower bound of B. Lower bound of B. Lower bound of B is again corrected value. Corrected value is given as 0.5. Then plus degree of accuracy is given as what? 0. Correct to 1 decimal place. 1 decimal place means the degree of accuracy to be used in lower bound and upper bound formula is 0.1. Then you write the 0.1 here. 0. Divided by 2. Then after calculating this, you get how much? 0. You have to deduct. Sorry. Lower bound correct value minus degree of accuracy to right. Then you have to deduct 0.05 from this one. Then it will be 0.45. 0.45. Then right now we have enough data to find the lower bound of the sum of A and B. Now go and substitute here. Now this one lower bound of A is 15. Then minus. Sorry, here formula. So I'm mistake here. There is a minus. I'm sorry. Plus. Okay, right. Okay, it's plus. Lower bound of A plus lower bound of B. Right. Okay. Then 15. Then 15. Then 15. Then 15. Then 0.45. Then 0.45. Okay. 0.45. You have to add. Then it will be 15.45. Right. This is the lower bound of the sum of A and B, that is 15.45. Now range. Now range of sum. Then range here. Range of sum equal how much? This one. How to write? Look at the lower bound of sum. Lower bound of sum is 15.45. Then less than or equals always. Then actual sum. Then less than upper bound of the sum. Upper bound of the sum is how much we found? 25.55. 25.55. Right. Okay. So that is the answer. We have answered all three. Okay. The upper bound, upper bound of the sum, lower bound of the sum, and the range of actual sum. Then lower bound of the sum of some corrected values is equal to the sum of the lower bounds of the corrected values. Then upper bound sum of corrected values is equal to the sum of the upper bounds of the corrected values. The lower bound of sum of corrected values is equal to sum of the lower bounds of corrected values. Right. So that is how we find the upper bound and lower bound and the actual range of sum of given corrected values. Right. That is the end of today's video. Before ending, I must remind you that it is worth to subscribe this channel and stay with us, because we are continuously uploading videos in this channel to help you improve your mathematics. So therefore now tomorrow I'm uploading an interesting video, and anticipate that. And until tomorrow, see you, goodbye. Wish you a very, very nice time. Thank you.